So we're going to look at a couple just applications or different scenarios for working with differential equations here. Okay, so you've got a curve that passes through the point 0, 5 and has the property that the slope of the line of the curve at every point P is twice the y-coordinate of P. What is the equation of the curve? So we have to write our own differential equation here. So, and clues about that are things that we are looking for the equation. We know something about the slope. We know something about the point. So first, let's write this as an equation. So the slope of the curve at every point P is twice the y-coordinate of P. So in other words, dy dx is always equal to 2y. That's what this is telling us. So now we get to just start solving our way through here. Great time to pause the video and try on your own. So let's multiply both sides by dx, and let's divide both sides by y. So you'll have 1 over y dy equals 2 dx. From there, let's integrate both. So you have the natural log of the absolute value of y equals 2x plus c. Substitute in your initial condition to get that the natural log of 5 equals 2 times 0 plus c. So c is the natural log of 5. From there, you can say, all right, the natural log of the absolute value of y equals 2x plus natural log 5. Let's exponentiate both sides. So absolute value of y equals e to the 2x plus natural log of 5. Good idea to recognize on the right-hand side that that's e to the 2x times e to the natural log 5. So absolute value of y is 5 times e to the 2x. So y equals positive or negative 5 e to the 2x. Check your initial condition. When x is 0, y is supposed to be 5. So let's see, 5 times e to the 0. So we need to choose the positive one here. So our answer is y equals 5 e to the 2x. Would not be incorrect to leave your exponent as 2x plus natural log 5, but it's a lot neater to see it this way, and I guarantee you that's how they'd show it on a multiple choice section of the test. Okay, application. The rate of change of bears n in a population is directly proportional to 350 minus n. Time t is measured in years. When t equals 0, the population is 100, and when t equals 2, the population is increased to 250. Okay, so they're not only giving us an initial condition, they're giving us some other kind of condition, a subsequent addition. I don't know. So first, though, we have to write our own differential equation. So we know the rate of change of bears n. So that sounds like dn dt in a population is directly proportional to 350 minus n. Well, directly proportional means I've got to multiply by some constant k times this 350 minus n. Okay, so let's separate. Now don't be confused, k is not a variable, it's just a constant. So let's divide the 350 minus n to the left and multiply the dt to the right. I'm not going to distribute that k and then try to like add n to the right-hand side. It's just going to become a mess. So, all right, so we've got 1 over 350 minus n equals k dt. Oh, I forgot my dn over here. All right, so let's integrate both sides. So on the right, you're going to have a kt plus c. On the left, you actually have to do a u substitution, whether you're kind of doing this one in your head because it's kind of a straightforward one, or you're writing it out to the side. Let's see. I would do u equals 350 minus n, which means that du is negative dn. So negative du equals dn. So I'm looking at the integral of, so the negative integral of 1 over u du, which gives me negative natural log of the absolute value of u. So on this left, I have negative natural log of the absolute value of 350 minus n. Okay, so I've got to figure out what k and c are here. I think I might deal with that negative first. It's kind of annoying me. I think I'm just going to divide it over to the other side. So negative ln 350 minus n equals negative kt, but I get to still call this one plus c. If you really want to make it a minus c, whatever. But that one, being that constant of integration, remember, it is arbitrary. So if we're just like multiplying, dividing it something by some other constant, we can just keep calling it c. All right, so let's sub in. If t is 0, the population is 100. So that's ln, absolute value of 350 minus 100 equals 0 plus c. So c must be the natural log of 250. Okay, that's not awful. So what do we have so far now? We have natural log, let's change colors. So now we've got the natural log of 350 minus n equals negative kt plus the natural log of 250. Still need to find k, so let's use our second condition that when t is 2, n is 250. So that's the natural log of 350 minus 250 equals negative 2k plus the natural log of 250. All right, so that's the natural log of 100 on the right. Let's subtract the natural log of 250, and let's divide the whole thing by negative 2. And that's our k. Okay, well, I could simplify this sum. I could use some logarithm properties in the numerator to make that the natural log of 100 over 250, all over negative 2. So that's the natural log of, let's see, I guess that's 2/5 over negative 2. Okay, so that's k. So my equation now looks like, putting it all together, we've got the natural log of absolute value of 350 minus n equals the negative of my k, so that means positive ln of 2/5 all over 2 times t plus the natural log of 250. Okay, exponentiate both sides. Left-hand side then becomes absolute value of 350 minus n equals, okay, here we go, e to the natural log of 2/5 all over 2 times t plus the natural log of 250. All right, let's use that exponent property to recognize that this is just 250. So we have 250 times e to the, okay, I see that natural log and that exponent. So I think I'm going to think of this as ln of 2/5, all of this, times the t over 2, or to the t over 2 power. And that is using that power of a power product property. So this becomes 250 times 2/5 to the t over 2. Don't you dare multiply 250 times 2/5. All right, 2/5 has an exponent on it, it's got to stay. Okay, so this is all 300, absolute value of 350 minus n equals that. All right, so 350 minus n equals positive or negative 250 times 2/5 times the t over 2. Let's subtract the 350 and divide everything by negative 1. Oh boy, I better do that in 2 steps, so I'm going to mess that up. Okay, so negative n equals negative 350 plus or minus 250 times the 2/5 to the t over 2, divide by negative 1, n equals 350 plus or minus 250 times the 2/5 to the t over 2. Let's use that initial condition to figure out if we need positive or negative. All right, when t is 0, n is 100. So 100 equals 350 plus or minus 250 times 2/5 to the 0. So that's going to be 250. Looks like I'm going to need the minus here to hit that 100. So final answer here, n equals 350 plus 250 times 2/5 to the t over 2. Now see, that wasn't so bad. All right, next question. If you're going to find the bear population in 3 years, you would just plug in that 3 for t and find your answer. I'll post the answer a little bit later for you, but that's what we would do. Just plug in 3. So one thing to remember before we go here. Remember that everything you've learned about antidifferentiation is on the table. U substitution, inverse trig, you name it. Anything we've learned to do with integration, you might have to do within the context of a differential equation problem.